Hey guys, let's discuss new round, which is round 9, and it is architecture round. Okay, so here, let's say they are asking you to design Amazon's order processing platform. So now we will be seeing here answer based on three roles. The first one is software engineer, second is senior software engineer, and third one is principal engineer or architect. Okay, so when someone will give you this order processing design Amazon's order processing platform. Okay, so this is just 2 minutes. Okay, so this is one of the most important Amazon senior SD principal engineer architect interview round. Okay, because it evaluates your ability to design mission critical distributed system. Okay, now what is mission critical distributed system? Which is critical for the business, right? Which brings business, correct? So a mission critical system is highly reliable system where downtime or failure can cause significant business or customer impact. Okay, so now Amazon's order processing platform is at the heart of the business, right? Because order is the one which is generating revenue, right, for Amazon. So the interviewer wants to see whether you can design a system that is highly available, fault tolerant, okay, and then event driven. After that, scalable, consistent where required, and then cost efficient and operationally excellent. Now they are not looking for the monolithic checkout service, right? So what they are looking here, they expect you to decompose the platform into services, okay, different microservices, let's say. Discuss distributed transaction resilience and operational trade-offs. Okay, so now again, expectation differ by level. So for example, software engineer end-to-end order flow and core services, right? And then senior software engineer event-driven architecture, Saga, Retry, Idempotency he can discuss. And principal architect he can discuss enterprise platform. Okay, enterprise platform with multi-region governance, observability, and long-term evaluation. So software engineer, 3 to 6 years of experience. Okay, he expected to answer for this question is, see, before designing the system I would clarify a few requirements. So he will ask that he will ask a question around this design, that what is expected from him. So for example, do we support physical product only or digital product as well? Then is this a global platform? Okay, then what is expected order volume? After that, should inventory be reserved before payment, and is order tracking required? Okay, so at the end what he will assume that I will assume a global e-commerce platform. Okay, it is globally distributed global e-commerce platform handling millions of order per day, so means millions order. Okay, now here is the high level architecture. So customer request will go to API gateway, from API gateway it will go to order service. Now I told you that here you will not discuss monolithic service, right? Means monolithic application. Here you will divide that into multiple microservices. So order service will then talk to payment service, then inventory service, shipment service, and notification service. And at the end, order will get saved into the database. Okay, this is the high level architecture. Now order flow will be something like this. This is what software engineer will explain. Customer places an order. Okay, validate the cart, verify that all selected items are available, quantities are valid, prices are correct, and any discount or coupons are applicable. Then reserve inventory. Okay, after that process payment, and then create the order, trigger shipment, and then send confirmation. So this is the normal flow. Now senior software engineer, 7 to 12 years of experience, he will say that the expected answer would be, I would separate every business capability into an independent microservices and use an event driven architecture. Okay, he will use event driven here. Long running workflows like payment, inventory, shipment, notification should communicate asynchronously. So here he is talking about asynchronous communication instead of synchronous one. Okay, now production architecture will be like this. Customer request will go to API gateway, from their order service. Okay, now he has introduced one Kafka layer in between that. Okay, event bus, because event driven architecture. Then payment service, inventory service, shipment, notification, analytics, and fraud services will be here. And after that it will go to order database. Now key design decisions will be something like this here. First he will use the stateless service. Okay, we have discussed many times what is a stateless service. So services that do not store user session data, okay, making them easy to scale and replace. If user session data is stored in one server, then how you will use the concept of scalability, okay? You cannot send that request to any other server because your session is stored in one server, only particular server. That's why. Now Kafka for event streaming, okay, so use Kafka for reliable publish and consume events between services in real time. Then Saga Pattern, so manage distributed transaction by coordinating multiple local transactions with compensation steps if something fails, okay? Idempotent consumer, so ensure processing the same event multiple times produces the same result without duplicates. And retry with exponential Backoff, so retry failed request with gradually increasing wait time to avoid overloading the system. And then few more dead letter queue, okay, so he will talk about DLQ, store messages that cannot be processed after multiple retries for later investigation. And centralized monitoring, collect log metrics traces from all the services in one places for easier monitoring and troubleshooting. And audit events, record important system actions, okay, who did what and when for tracking, debugging and compliance. So now principal architect or principal engineer or architect, what he will expected to answer here, that he will say at Amazon scale, the order platform is globally distributed event driven system, right? He's talking about global platform, global distributed event driven platform. And every business capability should evolve independently while maintaining reliability, auditability and consumer trust, okay? Now so the design should minimize synchronous dependencies and support regional isolation, okay? Now here enterprise architecture will look like this. So route 53, okay, request will go to global traffic manager, and from there it will go to regional API gateways, okay? Like in AWS you have multiple regions, so you have API gateways distributed there, and API gateways so in different regions, and from there it will go to order platform gateway, okay? Order platform gateway will connect to different services: order service, payment, inventory, shipment, fraud, notification, then return service, customer service, okay? From there it will go to Kafka platform. Now from Kafka platform it will go to event store, okay? It will store the event, audit and then analytics and reporting. So now here from there you will have a multi-region databases, okay? Not the simple database but the multi-region, cross-region database, you can say. So like for example in multiple region you have that database, and then cross-region replication you have. So one region's database you have replicated in another region's database, okay, and another region. Then global object storage you will have like S3 or something, okay, replicate across regions. And monitoring platform, so what you will monitor there, the metrics, logs, traces and alerts will be there, okay, in monitoring platform. Now so what architecture will say about the design principles, he will say about event driven communication, okay? This is the first thing what he said. So services communicated by sending and receiving events instead of calling each other directly, okay? Then second is domain driven design, so organize the system around the business domain such as order, payment or inventory, okay? So DDD we will apply here. Active region, run the application in multiple regions simultaneously so traffic continues even if the one region fails. Seal based architecture, so split the system into small independent seals so failures stay isolated, okay, in that seal only, particular seal. So independent deployment, deploy each service separately without affecting other services. Zero single point of failure, so ensure no single component can bring down this entire system, okay? Always have the replica of that, either it is a server or database, API gateway or load balancing things, okay, or the Redis cluster or the Redis, okay? So just create a cluster where you will have a copy of those components. And after that comprehensive observability, so collect log metrics and traces to monitor and troubleshoot the system. Now cost aware operations, so optimize infrastructure and resources usage to reduce cloud cost while maintaining performance. Now let's talk about follow-up questions here, and we will be discussing around 19 follow-up questions in this video, okay? The first one is order lifecycle. So software engineers typical state would be something like this, that order will created and then payment will get processed. Okay, so payment pending. After that, once it is confirmed, the order will get packed, shipped, and then delivered. Okay, simple flow. What senior software engineer will say, he will represent the life cycle of a state management and emit events for every state transition. Okay, because he's talking about event driven architecture here. So after each state he will emit the event. Okay, for example, he will start from here. Okay, this is the order lifecycle state machine, you can say. And he will start from here, then order will get created, so order created event will get emitted. Okay, so what it will emit, order created means order has been created. Now then, payment pending, so same thing. Okay, confirmed, packed, shipped, delivered. So for each state, event will get delivered. So now architect, what he will say, that every transition should be auditable, idempotent, and versioned to the to support analytics, compliance, and customer support. So here he is talking about the organization wide things what we need to check. What, like senior software engineer said that each state at each state we will emit the events, right? So but that event should be auditable. Okay, you should have the immutable data stored there. So for example, it should be auditable, idempotent. Okay, that is also important. And then versioned to support analytics, compliance, and customer support, something like this. So order gets created, so it will transition to from created to payment pending. Okay, next stage. But when you're transitioning it, so version audit events, so you need to version audit event which is immutable, you cannot change it. So for example, you will see here event ID we are storing, right? Order ID, then from state to state, timestamp, actor, and metadata. So this is we are for the auditing purpose we are storing these values, and append only event store. So immutable ordered version. After that, it will go to this order version, immutable ordered version. Okay, and these things will use by the downstream services, like for analytics you can use this audit events. Okay, which will like order funnel and conversion, cycle time analysis. Okay, and then operational dashboard. For operational dashboard you will use it, cohort and trend analysis, like similar for the compliance and audit, customer support. Okay, so this is how the diagram will look like after that, after this versioned audit events. Okay, now here this system is auditable, okay, idempotent, versioned, ordered, and analytics ready. Okay, let's talk about follow-up question 2, which is related to payment orchestration. Okay, payment orchestration. So software engineer will say, call the payment service after validating the cart. Correct, so you will validate the cart, yeah, the quantities are correct, and then the inventory is there. So you will start the payment service, right? A senior software engineer will say, use asynchronous payment processing with retries and idempotency to avoid duplicate charges. Okay, now architect will say, coordinate payment through a Saga workflow, handle authorization, capture refund, and compensation independently. Saga means you have a multiple microservices, the transaction will be going to multiple microservices. Okay, and then if anywhere it is failing, so you should compensate the earlier stages, like the refund or something. Now follow 3 is related to inventory management. So software engineer will say that reserve inventory before confirming the order, which is very important, right? You, before confirming the order, you need to see that whether you have this much inventory in your warehouse or not. Senior software engineer will say that inventory reservation should expire automatically if payment is not completed. Okay, after that, so that other person can use it, right? We are locking it for some time. Architect will say that inventory should be managed by a dedicated service with reservation events, optimistic locking, and compensation logic. So optimistic locking, we have discussed that see, you can read 2 orders at the same time, user can read it, but when they are going to write for that order, you need to check the version. Okay, so for example, the versioning is 2 for me. Okay, and then other user also, he has read it, so the version is 2 for him also. Now at the same time we are not at the same time. So let's say while we are reading it, I have updated the order, so version will become 2 to 3. Now when another user is updating the order, that time he will see that version has been changed, because initially he got 2 and now it became 3. So he has to again pull the data, latest data, and then he can update it. Okay, so this is called the optimistic logging. Follow-up 4 is related to shipment service. So shipment service means software engineer will say that create a shipment after payment succeeded, correct? Senior software engineer will say that publish shipment request, because he is talking here about event driven architecture, through Kafka, so fulfillment system process them asynchronously. Now architect will say a shipment orchestration service decides how and from where an order should be shipped. Okay, so that is what shipment orchestration will take care. It should support multiple carriers. Okay, so it means that choose between FedEx, UPS, DHL, Blue Dot, etc. Then apply routing rules. So decide the best shipping method based on the destination cost, speed, and packaging sizes. Okay, package sizes. Then optimize warehouses. So it means that ship from the nearest or most suitable warehouse to reduce delivery time and cost. Okay, and then you will have an integrate tracking. So collect tracking updates from carriers and ship the shipment status to customers. In one line, a shipment orchestration service intelligently chooses the best carrier and warehouse for each order, provided real-time shipment tracking. Okay, now follow-up question 8 is related to event-driven architecture. So software engineer will say services communicate through events instead of direct synchronous calls, right? Asynchronous calls we will be using. So senior software engineer will say event reduces coupling and improve scalability. That is for sure, right? Each services consumes on the events it needs. Architect will say define clear event contract, schema versioning, governance, replay capability for long-term evaluation. Now what is all those things? Let's discuss. So clear event contract, what does that mean? That define a standard format for events, so all services understand them. Okay, standard format for the events. Second is schema versioning. So means allow event format to change without breaking existing services, backward compatibility. Then governance, so manage and approve event definition to keep them consistent. Replay capabilities, reprocess old events if service fails or need to rebuild it. It's a data. Okay, so now in one line, use standardized versioned events that can be evolved safely and to be replayed when needed. Now follow-up question 6 is related to Kafka. So software engineer will say that once order created, it will go to Kafka. Okay, it will publish the event, then inventory, payment, and then the notification. Now senior software engineer will say that use Kafka partition for scalability. Now here he is talking about partitions, multiple partitions we have seen in Kafka, right? Messaging queue. Consumer groups. Okay, first is partition, second is consumer groups for parallel processing. Lots of consumers you will be adding. Okay, lots of consumer group you will form so that everybody will read, and so parallel processing you can use, and replication for fault tolerance. So 3 things he's talking about: partitioning, consumer groups, and replication. Now architect will say design topic ownership. Okay, now inside a partition you will have a topics, multiple topics, so that topic should have the ownership. Partition strategy, retention policies, exactly one's consideration where required, and monitoring for consumer lag. So he's talking about more in detail, architect. Now follow question 7 is related to Saga pattern. Okay, because you are using here distributed transaction and applying for multiple microservices. So software engineer will say that Saga coordinates distributed transaction using local transaction. So it means that, let's say reserve inventory, you have reserved the inventory, payment, after that payment will get processed. Okay, then shipment, and then success, but somehow payment got failed. Okay, so in that case the local transaction got failed, right? So it will go to reserve inventory, and then it will compensate the event. So if payment fails, so it will release the inventory. That will be the compensation step for him. Now senior software engineer will say I would implement choreography or orchestration depending on the workflow complexity. We know that event driven Saga, we use the choreography or orchestration pattern, right? Microservices pattern, it is design pattern. So compensation actions undo complete step when later step fails. So that is the compensation, means just undo everything. Choreography. So what is choreography and what is orchestration here? See, choreography is each service reacts to event independently without a central controller. Okay. Means let's say you have this some services, and this one will emit the events. Okay, then this service will get the events, then it will take whatever is required for him, and then again it will broadcast the event. Then this one is also something like this. You don't have any central coordinator, but in orchestration, a central coordinator controls and manage the entire workflow between the services. So all the service will send the event to this central coordinator, and then this central coordinator will send the required event to the required service. Okay, not all event will go to all the services. So now here compensation action is undo previously completed steps when the later step in the workflow fails. Now architect will say that use orchestration for critical business flow requiring visibility and governance, keep compensation idempotent and independently retriable. Okay. After that, use orchestration for critical business flows requiring visibility and governance. What does that mean? So use a central coordinator to manage important workflows so they are get monitored, controlled and troubleshoots. And here one more thing we use, that keep compensation idempotent and independently retriable. So what does that mean? So design rollback systems so they can be safely retired, okay, multiple times without causing duplicate or incorrect results. Now follow-up question 8 is related to Outbox pattern. So what is Outbox pattern? So write the database changes and event to the same transaction. Okay, then publish the event asynchronously. Why? Means database changes and event both you will write that with the same transaction. So if anything fails, another will also get rollback. Okay. Why? So it prevents cases when the database is updated but the event is not sent. Okay, or the event is sent but the database update fails. Okay, so in one line, save the data and event together, then publish the event later in the background to ensure reliability. Okay, now senior software engineer will say about Outbox pattern is that it will guarantees that events are not lost even if the application crashes after committing the database transaction. Okay. Architect will say that combine Outbox pattern with change data capture, okay, CDC, to reliably publish events while avoiding dual write inconsistencies. Okay, three things he has used. He said that with Outbox pattern, use the CDC, change data capture. If any changes occur in database, it will capture it. Okay, and in Outbox also we are doing the same thing. We are updating database and we are storing the events. Okay, so that to reliably publish, so both things we are checking. Okay, so that it will get confirmed, to reliably publish events while avoiding dual write inconsistencies. Okay, so what is Outbox pattern here? Save the database update and the event at the same transaction to ensure both are recorded together. This is what we saw. And what is change data? Change data capture is automatically detect database changes and publish them as events. Now avoid dual write inconsistencies. What is the meaning of that? So prevent situation where the database is updated but the event is not published, or vice versa, keeping data or events consistent. Okay, now follow question 9 is related to retry strategy. So what is retry strategy? See, a software engineer will say that retry temporary failure with exponential backoff. Okay, try in 1 second, then 2 seconds, then 4 seconds, not every second. Okay, senior software engineer will say retry only transient failure. Okay, and then limit retry attempts and make operation idempotent. Three things. And architect will say centralize retry policies, add jitter means some delay. Okay, to reduce the retry storms. Let's say a few services are getting failed, so everybody will bombard the request to the database. That should not happen, so just add some jitter, okay, some delay for those requests to reduce retry storms and monitor retry success rates also. Now follow-up question 10 is related to DLQ, dead letter queue. So software engineer will say messages that repeatedly fail processing are moved to DLQ. Senior software engineer will say monitor DLQ continuously and provide replay mechanism that after issues are resolved. Okay, then architect will say DLQ should be classified by failure type. Right, you have different DLQs, and then failure type, on the basis of failure type it will go to those keys, those queues, sorry. Integrate with alerting and regularly reviewed to prevent silent message loss. Follow-up question 11 is related to idempotency. So software engineer will say use an idempotency key so repeated requests don't create duplicate orders. And here senior software engineer will say that store processed request ID and return the original request for duplicate request. Even if duplicate request comes, so just store the previous one, succeeded one, okay, and then return the same one. So now architect will say apply idempotency across APIs, okay, and then event consumers and compensation workflows to ensure safe retries. Okay, follow-up question 12 is related to high availability. So software engineer will say deploy multiple application instances behind a load balancer, okay. For one server, just have the multiple copies and deploy your application in all the servers. Senior software engineer will say eliminate single point of failure using redundant services, replicate databases, and health check, okay. Now architect will say design for regional isolation, multiple region you will have the deployment, automated failover, okay, if anything fails, one region fails, so request should automatically go to another region, rolling deployments, okay, and continuous health monitoring. Follow-up question 13 is related to multi-region. Software engineer will say that deploy services in multiple regions for better availability. Senior software engineer will say replicate critical data and automatically route traffic to healthy regions, okay. Replicate critical data, he's saying. And then architect will say use active region deployment with clear ownership of regional failure, asynchronous replication, and traffic management. Okay, next follow-up question is related to disaster recovery. So this asks how, if something fails, how you will recover, okay, the things. So software engineer will say that maintain backups and deploy services in multiple regions. This is the simplest thing, okay. Maintain the backup and deploy your services in multiple regions. Senior software engineer say define RTO and RPO, okay. Targets, we have already discussed what is RTO RPO. And targets automate backup and regularly test recovery. So and then just take backup of your database or your application, okay, time to time, and regularly you test the recovery, whether your recovery system is working or not. Architect will say conduct disaster recovery drills, automate failovers, and ensure no single dependency prevent order processing. Follow-up question 15 is related to fraud detection, okay, how you will detect a fraud. So software engineer will say validate suspicious order before shipment, right? Validate order, he's saying. Senior software engineer will say publish order event to fraud services. Whatever you updated means user has ordered something, right? So just publish the order event to the fraud service. That service will check, and that evaluates the risk asynchronously without blocking most orders, okay. So user doesn't have to wait, but parallelly that service will detect whether it is a fraud or not. Architect will say use a layered fraud platform, combine rules, okay, combining what it will have rules, machine learning, device signals, and behavioral analytics while allowing manual review for high risk cases. Okay, follow-up 16 is related to audit logging, okay. So you have to log the events as well. So record every important order action with timestamps. Senior software engineer will say generate immutable audit events for order creation, payment, inventory changes, shipment, and cancellation, okay. So immutable audit events for each services. Immutable audit events means you cannot change it later, then only it is acceptable for the audit, right? Architect will say audit log should be tamper resistant. What is tamper resistant? Means protected from unauthorized modification or deletion. You cannot modify it. Immutable. Searchable, okay. Audit log should be tamper resistant, searchable, retained according to compliance requirement, and separate from operational logs, okay. Operational log should be separate, and this audit log should be separate, okay. Then after that, follow-up question 17 is related to cost optimization, how you will optimize the cost. Software engineer will say that use asynchronous processing and scale down unused resources after peak traffic. Let's say at night time you don't have that much traffic, so why to use n server? Use some lesser amount of servers, okay, and then use the asynchronous processing. So the things like generating report and all this kind of thing you can do at the night time also. So use asynchronous processing. Senior software engineer will say, optimize Kafka partition. Okay, he is saying to optimize your Kafka partitions, auto scaling. Okay, then storage lifecycle means hot storage, warm storage, cold storage. Different storage will have the different prices, right? Cost. Then cache utilizations also. Architect will say continuously optimize compute, storage, messaging, and data transfer cost. Okay, while monitoring cost per order processed and maintain SLOs, service layer objectives. We have already discussed what is SLO, SLA, all those things in earlier rounds. Now follow-up 18 is related to event sourcing. So software engineer will say that instead of storing only the latest order state, store every event that changes the order. Okay, and then senior software engineer will say event sourcing provides a complete history of state changes and enable replay, debugging, and audit capabilities. Architect will say that I would use event sourcing selectively for domain requiring storage, strong auditability. So only for the required domains only he will use, not everywhere he will use. Not every service benefits from it because it increases complexity, right? Now, follow-up question 19, which is the last follow-up question, which is related to CQRS. CQRS is command query responsible segregation. Okay, this is also a microservice pattern, design pattern. So what software engineer will say about CQRS is that use separate model for writing and reading data. Okay, let's say you have a primary database and then read replicas of those database. So you will do update, means writing the data from one database and will read from another databases. Senior software engineer will say that command update the order state while optimize read models serve customer queries without impacting transactional workflows. So this is the use. He's also saying the same thing actually. And CQRS, architect will say that CQRS is valuable for high read system like order tracking. It allows independent scaling of read and write paths while accepting eventual consistency. So that's it. Thank you.